2 and 1 and go. Area and volume. We have area between, we talked about on Friday. We have calculators, sometimes we can use. We have water. Water's a good thing. We have, what was I talking about? Discs and washers and cross sections and all sorts of in between. So, you can like all of those multiple choice might come. And then either the FRQs, the odds, the evens are your own thing, remember that's bonus, etc., etc. Okay, what questions do we have on area and volume?
Can we do the 11 question?
Yeah, we can do whatever. What do you want?
6.
11 and then 6. What else? Any FRQ-ish ones?
Can we do 8?
Yeah. Just call them out, guys. You don't need to raise your hand.
The FRQ is number 1 for Larry.
That are 8 for both? Okay. There were only 2 FRQs?
Yeah.
Oh, both of the odds. Is that what you mean?
Yeah.
Okay, got it. Anything else? Well, what's going twice? 12. Oh, the multiple choice. Okay. Let me go ahead and get started on the ones that we have because you guys just kind of ran silent and that means we're wasting time. So, graphing calculator stuff. Let me go back to number 6. I think that was the first question that we had. And as I am getting this ready, let me get my calculator open because as I just talked about, there are a couple graphing calculator. Hopefully we know how to use it. Hopefully the setup was what was harder. But either way, just so we can be prepared. Okay, let's get some work done. Sound good? If not too bad. Here we go. We're getting work done anyway. Number 6 is a non-graphing calculator, so you have to be able to visualize it, except it's a basic. You guys know why I have the basic graphs for again? There we go. Because the basic curves tend to appear. So we have y equals x squared. Cool. The line x equals 3. Hopefully we know that's a tick mark on the x-axis. And the x-axis. So if you guys remember, when they're giving you this volume and it says between, now it's kind of awkward because maybe the grammar isn't totally right because they're saying between and saying 3 things, but either way, it is technically between those 3 things. So we have the curve first, we have x equals 3 second, we have the x-axis third. Guys, there's only one region that has each of those 3 as a boundary. So as we go ahead and P.S. the library is closed all day today, don't try to get it. Okay, AP exams, it is what it is. We need to set up a few things, like, what do you guys think for this region? Top, bottom, or right, left? Are we doing dx or dy? Yeah, top, bottom sounds good to me. Alright, so we're going to go around the y-axis. That's why you guys didn't like it. Hold on, pause. Maybe we don't have an option. If we're going around the y-axis, question. What would the thicknesses of these circular cross-sections be? Vertical or horizontal? Vertical. Look at them. Guys, the thickness of the disc would be up, down. So therefore, I have to do dy. Struggle. All right. So v is equal to, now the question is, we know we have a pi and we know we have a dy. Hey, look at me go. And an integral. That's important. Question. For this region, spinning around, struggle. Is that a disc or a washer? Washer. Because as it spins, do you guys see the hollow inside? There's hollow on the inside, and you're going to have this funny, I don't even know what out here going on. So you have this funny thingamabob. It has like a cuppy hollow thingamabob. Anyway, so you don't necessarily have to get that picture. Remember, just ask yourself, right? Is this region flush with the axis, or is there some space? There's space. So if there's space, is that a disc or a washer? Washer. So I know right away that I need to go ahead and do big R squared minus little r squared. Now sometimes, guys, this is all you need to be able to match if it wasn't answers, if it was expressions. But sadly, these ones are answers. We have to go all the way. So now we have to go ahead and ask ourselves, what is big R, what is little r? Remember, the whole thing and the hollow. The whole and the hollow. You start from the axis that you're revolving around and you extend to the outermost. That's going to be the whole thing. Then you start from the axis. I just do it at a separate point so that we can easily visualize to the edge of the hollow. So one of them goes to the edge of the shaded, one of them goes to the edge of the blank or the white region. So, sadly top bottom doesn't work because we're doing dy. We have to do right left instead. If we have to do right left, something to keep in mind, dy, we have to go ahead and solve for x, which we're going to have to use square root of y. And that's going to be, I apologize, I just kind of labeled that without really thinking about it. Here we go. X equals square root of y is going to be that curve. X equals 3 we know is that curve. And then we know that the axis is x equals 0. So, for big R, right minus left is going to be 3 minus 0 squared. Because the right and the left of big R, that's going to be on the line x equals 3 and then the line x equals 0. Minus little r squared is going to be square root of y, the right, minus 0 to the left. So we have square root of y minus 0, quantity squared. That's all going to be in my integral with a pi. Oh no, what are my y bounds? How low does it go? 0. How high does it go? I don't know. 3, comma, what's the point of intersection? We'll plug in 3 to y equals x squared, and what do you get? 9. So it's going to be from 0 to 9. You need the y's. All places that you could have made mistakes. It is what it is. It happens. Bless you, bless you, bless you. Now the name of the game is solve. 0 to 9 of 9 minus, hey, square root squared. Isn't that just y? Life got easier real quick. How do we solve a definite integral? Let me down, guys. How do we solve a definite integral? Integrate, then plug in. Integrate, then plug in. Antiderivative of 9 is going to be, sorry, there's a pi. No, not derivative, not derivative. Antiderivative, 9y. Think the derivative of 9y is 9. None. Forever cards. Integral of a constant is the constant times the variable. Minus 1/2 y squared. From 0 to 9. Now we do FTC. Which number do we plug in first? 9. Good. So we have I times. 9 times 9 is 81 minus 1/2 times 81. Well, that's yucky. Plug in the 9, then plug in the 0. But the really nice thing about 0 in all this is, isn't it just going to be 0? Because that's going to be 0, that's going to be 0. Okay. Then we're ending up with I times 81 minus 81 halves. Some of you might see that that's just going to be 81 halves again, but for those of you that don't, you're going to go ahead and just multiply 81 by 2 over 2. You end up with 162 over 2 minus 81 over 2. All times pi equals 81 over 2. Oops, back to 2 times pi. Final answer is C. Done. Done. Okay, that was number 6. I think the next one was number 11. Oh, not number 8. Oh, great. We have the graphing calculator. Guys, to get this in our graphing calculator, what do we have to get by itself? The y. Good. So y is going to, hey, these are conic sections. You could divide both sides by 36. You could end up saying that x is going to end up going over 1 over 4 over 2. The y is going to end up 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And you're going to have this graph. But if you want to get this in your graphing calculator, not to think about conic sections. There he is. Instead, you have to get y by itself by subtracting and then square rooting. So you end up with 36 minus 9x squared. Plus or minus, technically, to get top and bottom. Top would be the positive square root, bottom would be the negative square root. Bless you. We have the region in between. You could get this in your graphing calculator now and say, hey, I'm spinning this whole thing around what? Oh, that's awkward. That's gonna be an oblate ellipsoid. Once again, most we don't want to think about it. And probably the hardest thing in this one's gonna be the bounds. Because even though we could shape all of the inside, let's just keep the ellipse for right now. Let's go ahead and say we're spinning around. And if we're spinning around, then we only need the radius, pi r squared. And the radius is going to be from, let me try to get a different color so I'm not like freaking you all out. There we go. From the axis to the top. I guess I don't need a big R, little y. And then we know it's dx because this is going to be dx. So we end up with v equals, the area is going to be flush, we can say it like that, there is no hollow going on. Once again, we have our little r that we're trying to figure out, top and bottom, r is only half the distance. Pi r squared. X bounds, I think I see -2 to 2, you guys should be able to see that in your graph as well. The top is just going to be the positive square root, 36 minus 9x squared. Radius, bottom is 0 technically, squared, and then dx. All we gotta do is plug and chug it to our calculator. Did anybody already do that and get it? Yeah.
I did this yet last night, but I got the wrong answer and I'm not sure why.
Did you do -2 to 2?
Yeah.
Oh, that's good. Has anybody plugged and chugged it? It could just be a graphing calculator thing.
Squared, actually. I don't know.
It's so easy to forget something small in this one. That's why a lot of people say before you circle an answer, just double check that you have, like if it's a graphing calculator, that you plugged it in right. Double check that you've gotten your formula right. Does anyone plug it into the graphing calculator? My advice, so that you don't do something stupid, throw your pi in front. Don't just always say, no worries, I'll remember it. Sure you will. Maybe you will, but still. I think you actually have to kind of like throw extra parentheses in. Or you could just say square root of a squared cancels. You know what I mean? Can we just do that little bit of math? Square root of a square root squared cancels. I typed everything in, right? I believe I got E. What's the correct answer? Oh, whew. Go team. So at Bridget, it might have been the squared.
Yeah, I just got it. I never got the square.
Good, good, good. It could have been the pi or the squared. It's so easy to forget either one. E, final answer. Number 11, I believe, is the next one. Oh, good. I was hoping someone would ask a cross-sectiony one. I know it's silly, but I like going over things that I know are tricky. That makes sense, right? Oh, we didn't get to this one on Friday. Kiddo, the same thing. If you're trying to look at this equation, well, how can we get a graph of it? There's no graphing calculator. Oh no, I don't know what x plus 2y equals 2 is. Someone, come on. What would help me visualize them better? Get y alone. Let me say that here. So then if I subtract the x and divide by the 2 very carefully, it's just a line. And we should know how to graph y equals mx plus b. Hopefully. Start with the y-intercept. Go down 1, right 2. Yes, what I loaded online actually had this one already solved because period 6 got to it. The video didn't, but. Pretend that actually connects the 2 dots. Anyway, the region formed by this graph, or between this graph and the 2 axes, there he is, forms the base for, the base for a solid. Cross sections perpendicular to the x-axis go straight down, are come up in squares. You guys don't have to draw the picture, but if you can, it does make life a little easier. For instance, maybe you can see now, if you slice it down, the side to the square is the top minus the bottom. The side to the square is just top minus bottom. That's the measurement of S. And why on earth am I talking about the measurement of S? Because our forever card. Am I saying that forever cards are important? Yes, what is tomorrow? Your forever final. Your forever final. Last chance to help out your final exam score. V equals the integral of a of x dx. The x bounds I see are 0 to 2, because we have x equals 0 right here, we have x equals 2 right there. The area of a square is side squared. P.S. If this is more motivation, I am updating all of the grades. Hopefully by tonight I can do some tutoring also. That includes your chapter 5, chapter 6 tests with corrections, however. Just saying, you need a good grade tomorrow. I haven't put in your mock AP yet. Chapters 5 and 6 to make sure. Top minus bottom, we end up with negative 1/2 x plus 1 minus 0 dx. The name of the game is just solve. Some of you get a little bit stuck in the solving. My advice is FOIL. I'm not really sure what else you could do. There's no like, well, I guess you could do use sub. I'm not sure if that would really be easier. So we have the integral from 0 to 2. Squaring negative 1/2 x times negative 1/2 x would be 1/4. Oops. I'm integrating. No, I'm not integrating. 1/4 x squared minus 1/2 is minus 1 x plus 1 times plus 1 is plus 1. Hopefully someone's double checking. There we go. When we integrate, we get 1/12. 1/3 times 1/4 x to the third minus 1/2 x squared plus x. Awkward, this one, the hardest part is, hopefully, well, there's a lot of tricky parts. Getting the graph, knowing the forever part, plugging it in properly, and then integrating. But if we plug in very carefully, we have integrated. Now it's time to plug in, Chad. We'll end up with, let me go way over here, 1/12 times 2 cubed is 8, minus 1/2, 2 squared is 4, plus 2, f of b minus f of a, 0, 0, 0, sweet, equals 8 over 12 ends up being 2/3, minus 2 plus 2. Then there's sinus cosine. You guys are in a totally different one. Is it B? Okay. It seems really small, but it is what it is. It's really small. Praise the Lord, number 12 is a graphing calculator one. However, if you notice it, oh, no way. Did you pull out a triangle on there? That's just mean. Some of you guys on the cross-sectiony one, you might want to actually cross-sectiony forever card. And this is a U thing. This is a U thing. If you want, you can write down the area formula to rectangles is base times height. The area formula for squares is side squared. The area formula for a semicircle is 1/2 pi r squared. For a quarter circle is 1/4 pi r squared. You should know the area of a circle is pi r squared. A regular triangle, if they're going to be nice to you, is just 1/2 base times height. An equilateral triangle is square root of 3 over 4 s squared. I've done the geometry this year to prove why it is what it is, but it's easier for you guys just to write it in forever card and memorize it just in case it shows up. If it does show up, though, it's only one question. If you're like, yeah, my brain can't memorize more than it's already memorizing, shouldn't still be memorizing. You should be remembering. But either, I think it's square root of 3 over 4 s squared. Let's see if it works. It's shorter than me having to do all the geometry to show you why. Basically, Pythagorean here. I think we have the exact same equation as above. Is that the exact same equation? That's weird. So that means we have the exact same picture from 0 to 1, 2. Cross sections perpendicular to the x-axis. All that's different is now we're popping up into an equilateral triangle where all the sides are the same. And once again, we can say the sides of the equilateral triangle is equal to top minus bottom. All that changed was the formula we're plugging it into. So we'll have the exact same. B equals the area formula this time is going to be this one. So we're going to have square root of 3 over 4. We still have our bound 0 to 2. We have our s squared, which is going to be our negative 1/2 x plus 1 minus 0. You want me to show it minus 0. Quantity squared dx. Phrase for the calculator, calculatrice, calculadora. So we go from 0 to 2. I just went ahead and threw in my square root of 3 because if we put it outside, sometimes people forget it's a thing. Go outside the square root, divided by 4. Now I have my negative 0.5 x plus 1 quantity squared dx.
Would it matter if you stick it on the outside?
No, just don't forget to stick it on the outside. Like the pie, it's easy to forget. How's it look? B?
Yeah.
Okay. And then I think we just have the 2 A's. And now that was good, so let's go and get that done. Oh, it's just the area. Okay. We have our F, we have our G. Kiddos, how on earth can you know who is who? It's a graphing calculator. Who cares? You can just plug it in and see it. But anyway, long story short, you end up with, this looks way more E-ish, that's G, and this is way more sine-ish, that's F. I think that's actually true though, not just me guessing. So we have F and we have G. They say F, G, and the y-axis, so figure that out with, okay, there's F, there's G, there's the y-axis. The region should just pop out of the page when you guys trace each of the boundaries. F and G and the y-axis, there we go. Area, everything's in terms of x, and its area I get to choose. Top bottom looks awful good to me. Except, I know that this is x equals 0. What don't I know? What's the other bound? A. Why do I say A? Because we should find it, because we have a graphing calculator. And then we could say, as long as we figure out the intersection, and we state it, A is equal to, and we stow it, we can say the area is equal to 0 to A of, top is F, of F of X minus G of X. Guys, don't lose stupid points and not write your integral properly. Some of you got OKs on your FRQs and you weren't writing your DXs. They can take off points for that. Write your integral properly. Otherwise, all we gotta do is go to our good old graphing calculator. It's a good time to review. I'm probably not gonna do it on the next FRQ so that we can get some motion done. But
If you didn't store a number, you just put a...
you could just write it all out. It just takes time, but you could just write it all out. Just include all the decimals.
Wrong,
huh?
That's not wrong.
Mm-mm.
What if I rounded the decimal point?
If you, don't round there. Only round your final answer there. So on your FRQ, instead of writing A, you would just write the whole decimal.
Okay.
See what I mean? And then you would plug in the whole decimal. Or you could cheat and like put in the A, but then you just type it in instead. That works too. So we have F is our e to the. I'm just doing this because, guys, you need to find an intersection, so we have to graph it anyway. Plus, it'll make it easier when I go to do my integral. There's my F, here's my G. So F is y1, G is y2. I'm guessing Zoom standard is good. This looks to be like 1.5-ish. We could change to be -4 to 4 to actually make it all nice and snazzy if you want. Remember, you can use what they give you and try, nope, not -1. And try to make your graph match. It helps your brain just kind of visualize it better. But as it goes, my normal talkers, just make sure it's productive. I see the juniors over there solving stuff. That's not bad. I'm more worried about my seniors. Or my juniors talking with seniors. Number 5, I have intersect. Um, 1.2834 yada yada yada. How do you stow it? Someone help me. You don't have to, but how could you?
Quit.
Quit first. Second mode, quit first. Immediate stow. Whatever is on your screen, quit and immediate stow from you having the intersection, then just make it whatever letter you want. And this one I'm just making it A because I don't need to store Avogadro's number or whatever you guys have in A. There he is. So I'm going to put my, I'll write it in a second. Then I'm going to go ahead and do my alpha. There, I get my integral. Ba-doop. Then I'm going to go from 0 to, because I'm cool like that, alpha A. And then I'm going to go to, because I'm cool like that, go get my y-vars. That's not the right one, it's one more over. There we go. I have y1, because that's where I put my f, and I realized my orientation, minus y2. Kiddos, would anything change if you accidentally switched which one you put in? And you did y2 minus y1 instead?
Yes.
Yes, it would be a negative. What would you make it? Because area between is always positive. So just keep the answer if you can't figure it out and make it positive. If you flip the orientation, you know there's no places to split up in between. You're fine. I'm going to go ahead and make my A my 1.2834. Oh, not with the highlighter. 1.28345. You can do dot, dot, dot. They get the point. You're keeping the whole thing. So that would be a good dot, 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 but just make sure your integral. Probably go rigid like 4 or 5 places in the middle. Just safer than sorry. And it ends up equaling, there's no, absolutely no work to be shown. 1 point, help me out. Is that 808?
008.
Oh, 008. The zeros and 8's confusing from the side. 0, 0. 8 is rounded, right? Okay, good. If you guys are stressed about rounding to the third, just make sure you have 3. They say rounded or truncated is fine. So you can just leave it the way it is and not round it at all. They will always count correct. Or round it properly. Don't round improperly. This one is very similar to the last one. Calculator is allowed, so I'm not going to go through all the process. I'm just going to set it up. For R, we see it right there. In your graphing calculator, you should be able to figure out that, well, even for basic graphs. This one is H, because that's your ln. And this one, well, A, he looks triggy, and B, I'm going to help because this is our region. This is H, that's our ln, that's our swoop, there it is. And then this one down here is our G, it's our triggy one. I see intersection A, I see intersection B. What you would say is something to the effect of intersections at A equals, comma, B equals. You would write it out and then you would say area is the integral. Since I can see the picture, let's just not even worry about absolute value. Put in A, put in B, say I know that H is on top, I know that G is on bottom, plug and chug it to that glorious graphing calculator you get to use every now and then, and you are done. Alright, cool kids, you want to get some work done in motion? Get some bonus? Alright, if you are ready for this thingamabobber, the odds are fully attempted, you've graded, because we take off points for grading. If you haven't graded, turn it in to me if you weren't here on Friday by tomorrow, and if you were here on Friday by the end of the day. Lauren and I are going to be working on busting out packets today, so that we can get them back to you guys tomorrow if you want to be doing evens for both.
Oh.
Does that make sense? And you have to study from because packets are great places to study. Alright, cool kids. Let's go ahead and... Oh, wait a minute. Hold on. The order's different. Sorry, if you're ready, pass them back, pass them over, pass them in. I'm going to my motion packeting thing. Oops, that's not motion. Motion. You guys go to motion and start playing. Motion wasn't in the same packet I thought it was. Alright guys, start playing with motion. Position, velocity, acceleration. Position, think of it as original, X or S. Velocity, think of it as S prime. Acceleration, think of it as S double prime or V prime. However, velocity can come from acceleration if you can use an integral. Integration as net change may come into play because if you're integrating, they might want one position at one time where you have to add an initial. Motion, motion, motion. There it is, review 11. Start. Nope. Oh no. I know. But that's why I gave it to you guys.
She didn't even try.
She doesn't like motion though, so she's just being a complainer for a little bit, and that's okay. No, that's okay. As long as you start, Bridget, as long as you start, that's okay. P.S. If total distance traveled and displacement show up, we have formulas for that as well. I think this is all loaded. Shoop, shoop. Let's see if I got it. That's just random because I just why are people talking about this? It's so annoying. I mean, not when. Not really. That's coming up. In like years. Hopefully, it doesn't have any hidden agendas. That's really sweet. It's okay. I thought it was good, but I also heard that hidden agenda that they may have to be a big deal because no one else would really do it. Well, some of them. Wasn't as obvious as others that they're going to be. Okay. Don't you do a good job? You did. Oh, there it is. I found it. There's a weird order. Dun, 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 dun. Don't worry, I'm waiting for the motion packet to load on my iPad. I'm not just sitting here. Question. What is the integration formula for total distance traveled? Integral to absolute value of velocity. Good, from A to B, E's and B's. Question. What is the integral of secant of UDU? Nope. Oh, yeah. No. The integral of secant. No. Of the cotangent. Absolute value of who goes with secant always?
Tangent. Cosecant.
Good. Secant and tangent, right? Derivative of secant is secant. I know, right? But this is a hard formula. Come back. Secant and tangent always go together. Right? Ready? Derivative of tangent is secant squared. Good. The derivative of secant is secant tangent. Secant has secant and tangent.
Oh,
The integral of secant tangent is secant plus c and then dx of the other. The integral of secant squared is tangent x plus c. The integral of secant is ln, absolute value of secant plus tangent plus c. It's just a funny one.
Wait, what's secant plus tangent? Or no?
The integral of secant alone is ln, absolute value, secant plus tangent. You guys need to look at the card with the funny ln formulas, integral of tangent, integral of secant, etc., etc. Question, what is, I'm not going to tell you guys like theorems or anything, you know to be studying those and you know your struggles. What is the integral from a to a of f of x dx?
0.
What does the graph of absolute value of x look like? Yeah. What is cosine of 2 pi over 3?
Negative 1/3.
Negative? I don't know if I said it. Negative 1/2. What is the derivative of a or b to the u, whichever one you like better? B to the u times ln b times u prime. What's the integral of a to the u or b to the u, whichever one you like better? 1 over ln of a or b times a or b to the u plus c. Plus c, plus c, plus c. What is L'Hopital's rule? If the limit gives you indeterminate form, then the limit of f of x over g of x is x equals to whatever is. Question. For first derivative test and or second derivative test of relative extrema. First derivative test or second derivative test of relative extrema. Where is the only possible place that relative extrema can occur and is also the first step of both tests? Find critical numbers. Find critical numbers. For the first derivative equals 0 or DME. For the first derivative test, make a sign chart where f prime changes from positive to negative, f changes into, that's going to be relative maximum. Where f prime changes from negative to positive, f changes from decrease to negative, to relative min. Critical numbers in the second derivative. F double prime is positive. What is it? Yes, but what is the type of relative extrema? Minimum. F double prime is negative. Get out of here. Study your forevers. First priority. The motion packet is due Wednesday. We'll go for questions on motion after the forever final tomorrow. Bye, bye, bye. No, but this is the AP. Oh, come on. If you're literally running out of room, you don't have to say stuff. I would even put it up here. Make sure it covers
You ate it! Get on my phone!
It's just, it's bonus, so technically it's do whatever. We'll go over questions after the final tomorrow. Okay. Like it. Oh, did you not have your sheet ready to do it now? Yeah. Sometimes people say they missed it and they just need to still make it up, you know what I mean, Andrea? So